If you remember, in the previous video, we have derived the mathematical model for a water tank system. The plant transfer function obtained was 4 over s plus 2. We can express this in Matlab as follows. First, let's verify that the hand-calculated closed-loop transfer function in the previous video in the S domain was correct. If you remember, we have assumed both the controller and the sensor transfer functions are 1. This leaves us with the plant transfer function and the forward path with the unity feedback system. So the closed-loop transfer function can be obtained as follows. If we assume capital T is our closed-loop transfer function in the S domain, then this can be found as and this is the same as obtained with hand calculation as shown in previous video. To find the closed-loop transfer function in the Z domain, we have first to assume a sampling time, considering the same sampling time used in the previous video. So the C to D means continuous to discrete. What it does, it converts the continuous time, linear time invariant model, which is the water tank model, GPS, using the zero order hold on the inputs with a sample time capital T. If you remember, there are other discretization schemes discussed before. The zero order hold is one of them. There is the triangular approximation, or what we call sometimes the first order hold. We have the bilinear or the Tustin method as well, which will be discussed in your project later on in a separate video. There are others as well, such as the pre-warp or the matched. When using the zero order hold, in this case we are assuming the control inputs are constant over the sampling period T. So what we have obtained just now is the forward loop transfer function equivalent in the Z domain. This transfer function combines the plant transfer function and the zero order hold transfer function together in the Z domain. Next, we will find the closed loop in the Z domain. Assuming now this is the only transfer function in the forward path with the unity feedback system, then the closed loop transfer function in the Z domain can be written as and this is what we have calculated by hand in the previous video. To cross-compare the step response of both the closed-loop transfer function in the continuous and the Z domain, we can write the following command. This is the step of the closed loop in the continuous domain. If we put this in blue color, that's the closed loop in the Z domain. If we distinguish this by the red color, perhaps we can add legends as well. So remember, the red response is that for the discrete closed loop transfer function, and the one in blue is the one for the closed loop continuous transfer function in the S domain. So the discretized response includes the zero order hold transfer function, and the sampling time has an important role in determining that transient response. Please remember that the steady-state response is identical for both systems. The value of 0.667 is in line with what was calculated by hand in the previous video. Let's change the sampling time to 0.03 and study the effects of this value on the transient response. It's evident that when we have chosen a smaller value for sampling time of 0.03, we were able to get a closer match of both the discretized and the continuous closed loop transfer functions for a step input. This clearly shows some of the effects of sampling on the system response, because previously when we chose a sampling time of 0.1 seconds, we can see that the discretized response in red is a bit experiencing delay as compared to the continuous response. To avoid such delay in the response, it's always preferable to choose a sampling time as small as possible, but obviously this will increase the load of the computation. On the other hand, choosing a big values for sampling period could make the system unstable. You could try a sampling time of 0.5. You may see oscillations. If you choose a bigger value, maybe of 1 second, you will have an unstable system. The main reason for this is low sampling rate, or a big value of the sampling period will make the roots outside the unit circle. We shall see this later in the coming videos.